When I was learning things like this, it like, oh yeah, that makes sense, no problem. And I go home and I can't even do the first step. Any of you experienced that? Yeah. All right, here you go. The sum k equals 1 to infinity of square root k over k squared plus 3. So think of a series that behaves like. Determine if that series diverges or converges, and then see if you can use it to prove divergence or convergence with this series. I'll just let you think about it for a little bit here. Try something, try some stuff. So what does this behave like?
It's like 1 divided by
Close. You say 1/2?
yeah, like 1 divided by square root and then k.
K to the 1/2 over K to the square? Or
Okay. So basically, for large values of k, the plus 3 has very, very little effect, doesn't it?
yep.
When you think about putting in numbers like in the billions for k or the trillions or whatever, the plus 3 down here has very, very small effect on that ratio, correct? So this behaves like the square root of k over k squared. Does that make sense? Now, you guys were saying the right things, but I think you had your arithmetic a little wrong over here. K to the 1/2, that's the square root. Okay? Now I'm going to erase this, but if we subtract 1/2 minus 2, need a common denominator. Oops, that's not the 1. 4 over 2. We get negative 3 over 2, right? So, behaves with the S. Behaves like this, 1 over k to the 3/2. What do we know about 1 over k to the 3/2? Yes. The sum of 1 over k to the 3/2 converges by p-series test, comma, p equals 3/2. That's greater than 1, right? Well, so we know this converges. This and this compare how? Is this less than or greater than that? For all values of k greater than or equal to 1. Because we're adding 3 in the denominator, we're making the denominator larger, right? Larger denominator makes the fraction smaller, doesn't it? So this is always less than that. Correct? Let's state it this way. less than that, which equals that 1 over k to the 3 halves. Let's state it this way. Since the sum, no, let me get these words in my head. Since the sum k equals 1 to infinity of 1 over k to the 3 halves converges by p series test, comma, the sum k equals 1 to infinity of our given series, square root k over k squared plus 3 converges by comparison test. And then we got this stated here, so there we go. Does this make sense? Yes.
Let's, you know how we did the little arrow thing as it implies, right?
Yes.
Can we also do that rather than having to write that?
You could write, well, you could put it in place of, that comma right here. This implies that. That would work.
But is
We need to see this statement somewhere that shows this is less than that, because that statement is what makes this statement true. All right?
so better than just something right like that, like do it in writing form rather than like,
I want you to write it.
oh,
Yeah, write it. You're not gonna have to write it in Pearson, but when you're doing Pearson, you should write it so that you verbalize it in your head. Does that make sense? All right, any questions here? All right, let's do a harder one. These were all, do you see how this is a pivotal series here? With the P-series test? If the exponent here is 1 or greater, this will convert, well, 1 or less, this will converge. If it's greater than 1, it'll diverge. That's a pivotal series right there.
The harmonic. Or just the P series.
Okay, another one, let's back up here. Let's go with the sum as k goes from 2 to infinity of ln k over k cubed. You know what, I think I should have, this k greater than or equal to 3, that's true, but it could be a 2. E, somehow, yeah, it could be a 2. So, because of this statement right here, we can say well, let's state that there. I'm going to state that ln k is less than k for k greater than or equal to 2. This implies that ln k over k cubed is less than k over k cubed for k greater than or equal to 2. Let that sink in. Make sure that makes sense in your head. So if ln k is less than k, that means this numerator is less than that numerator, which means this fraction has to be with less than that fraction. Do you agree? Does that make sense? All right. What do we know about this? K over, let's put here the sum as k goes from 2 to infinity of k over k cubed is equal to the sum as k equals 2 to infinity of 1 over k squared, right? That k cancels out one of those. And what does that do? Does that converge or diverge?
It converges.
It converges because?
Because 2 is greater than 1.
2 is greater than 1, and that is by what test?
P-series.
P-series test. Converges by P-series talking to me in my hearing aids. Converges by P-series test. Oh. Shut up, Siri. P-series test, comma, P equals 2.
A droid professor.
So we can say then, since the sum, k goes from 2 to infinity, of k over k cubed converges, the one we have here is k equals 2 to infinity of ln k converges by comparison test. Now, do you see what I mean when I said these tests are easy to understand, but they're difficult to apply?
Yeah,
Yeah?
it's easy to like mix, like to confuse concepts.
Anything in these statements that you need further explanation with, something that doesn't make sense there?
That was there other than K, like, how did you get the K divided by K squared?
So because we know ln k is less than k, I replaced ln k with k. Because I know, so this is where that hunch thing comes. Because we know this, ln k is less than k, our hunch should be that this is going to converge. Because k over this gives us the 1 over k squared that we know converges. So our hunch should be that this converges. So we're going to compare it with k over k cubed to prove it converges. And this is the obvious one because it equals this. This is the obvious one that converges. We know this one is always less than that because of this statement right here. So then we use that. This is where I was saying you have to develop an intuition to be able to have an educated guess about whether it's gonna converge or diverge. And then choose your series you're gonna compare with accordingly. Does that make sense? The only way we develop that intuition is by doing problems. It's the only way it's gonna happen. Just gotta do problems, do problems, do problems, get more and more familiar with these things to know what they're gonna do.
So say the expression was k to the fourth and then denominator, that would make the rest of it k to the fourth, right? You get 9k over k to the fourth, less than k over k to the fourth.
Yes, and it would work out all the same, only using that. That one would work out all the same.
What happened if K was less than 2?
But like if K is at one.
So the problem we have if k is less than 2 is right here. So if k was 1, natural log of 1 is 0.
This would be true.
It's
If k is 1/2, you would have, well, k has to be a whole number. You get in the problem, like if k was 1/2, you'd have to raise e to a negative power, I think, to get 1/2, right? No? If, what is natural log of 1/2? Okay, it's negative 0.6931, so on. So, for these things, k has to be, we gotta put it, we wanna use positive whole numbers for k. And like I said, if k was 1/2, this would be negative, that's gonna screw things up. By making k greater than or equal to 2, this stays positive. And that was one of the conditions for the test. It's probably not making very much sense. Says a sub k and b sub k be series with positive terms. If you let k be less than 2, you're gonna get negative terms in there. And then these tests don't apply. Does that make sense?
Is it a test? Does
We're not gonna go there. Yeah, we're not gonna go there. For the problems we're gonna do, they're all gonna be positive. They're rigged. Okay, they're rigged to make it work. So we're gonna run across a theorem that says if they are always non-increasing or non-decreasing after a certain point, then what happens after that determines convergence or divergence. And so then you just ignore what happens before. There's a theorem that says that. All right, let's do, what time is it?